What if robots could predict your next move and adapt to your work seamlessly alongside you? My PhD research explores how robots can become true teammates in assembly tasks. Traditional industrial robots follow rigid pre-programmed schedules. But what if tasks require flexibility? My research asked, can robots and humans achieve fluent collaboration through mutual adaptation, where the robot learns from you and you work together as a team? I addressed 6 key questions to make this vision real. First, can humans work effectively without speech? I set up a human participant study to measure gesture usage and comfort during collaborative assembly. I found that pointing gestures and manipulative actions alone enable successful coordination. Speech is not mandatory. Second, how can robot track task progress under occlusion? A ceiling-mounted depth camera observes the workspace but suffers from occlusion by human and robot. I developed a task state tracking system using Colored Petri Nets. It compensates for occlusion by tracking multiple hypotheses. The system achieves 95% accuracy with only 250 milliseconds latency. Third and fourth, can humans and algorithms predict assembly actions with limited information? My user study showed that human observers can predict the next assembly step with 60% accuracy. For algorithmic prediction, I designed a novel deep neural network. Instead of treating actions as simple class labels, I encoded them as context-rich feature vectors. The neural network matched the human's performance, learning incrementally during interaction without extensive pre-training. Fifth, does prediction improve collaboration fluency? I set up a user study for collaborative assembly supported by augmented reality. I tested 3 robot strategies that differed only in their choice of actions. The adversarial one, where the robot intentionally chooses conflicting actions, significantly decreased fluency. The adaptive strategy showed positive trends. This reveals that coordination alignment matters more than raw efficiency. Finally, how do objective and subjective metrics relate? Speed doesn't equal fluency. Fluency is orthogonal to task completion time but correlates strongly with mental workload and trust. This means we can't just measure productivity. We must measure how collaboration feels. This work demonstrates that robots can learn human behavior during interaction, creating adaptive teammates rather than rigid automation. Future directions include expanding the complex assembly tasks beyond pick and place and integrating gesture recognition for natural communication.